Okay, guys, welcome to my YouTube playlist Smarter R. So today I will show you how to do a very comprehensive missing data assessment by using R. So there will be a lot of statistic then that you can calculate for missing data that you can use uh, to to have a very good output for your missing data assessment, and also how you can visualize your missing data. So without further ado, let's share the screen. So everything will be using R. So I have shared the screen. Let's do something like this. So first, open your R. So this is we will learn today how to do a missing data assessment. So basically, there will be uh, four assessment or metrics that we will do. We will do some diagnostic. Actually, all of these result will have a lot of output other than simple diagnostic. And then we do standard deviation, and then we calculate the variance, and then we also can calculate the skewness and so on. Actually, there's a lot more. I will show you later on. So first, we use the library dlookur. Install your library dlookur in R. So if you don't have dlookur, you can just install it by using install packages, and then use the library pacman. Install the library pacman, and then ensure the package pacman is installed. You must write all of this pacman load package that you will require for this assessment. So you will need Rio here, janitor, Sybil, Lubridat, Scheme R, Tidyverse, GT Summary, dlookur, NYC Flight S13, or Tiny Text, something like that. You can just load all this package. Okay, now you have load all of this package. Okay, now we look at our data. For example, I have this. Actually, I will show another data that we have here. I will research garlic. So I put it all in this folder. So we must open our first working directory. This is our working directory, so we will work from here. So okay, so all our input data will be put here in this working directory, and also our output data also will be here. So set our working directory. Some mosquito. Sorry. Okay, set our working directory, and then our data set is, for example, I have this station for daily rainfall from 1970 to 2015. So station 21, 19 daily rainfall, 1917. Okay, this is our data. This is my data. This is for example. So we have here year, month, and day, and then rainfall data. I have 24 rainfall station, 21 rainfall station here. So actually there is a lot of missing data here. You see some station have missing data, some continuously, some of it, many way of data is missing. So you see NA here. So this is all missing data. All of this station, they have missing data. But we want to inspect this data set first. We want first, before we do missing data research on missing data, we must inspect the missing data first. We want to understand the data itself. How does the data looks like? Can we use this data or not? Okay, something like that. All of this based on the statistic. Okay, for example, this is our station data, but this is the data depend. If you have other variable, it's okay. It's up to you. But I arrange it based on the rainfall. So arrange everything based on the parameters, so that easy for us to see to make assessment of our rainfall station. So example, if we have rainfall station, just arrange all station 1, station 2, 3, 4, 5, 6 until all our station. And if you have all other parameter, you can arrange maybe teaming station 1, teaming station 2, teaming station 3, and so on in one CSV file. So this is my CSV file for rainfall. I have 21 station for Johor River Basin daily rainfall data. So all this station data for rainfall station, 21 station, I put it into one single CSV file. So I have year, month, and day. So my data is daily data. If you have monthly data, then monthly data is okay. So this is how the data is being arranged. Then and make sure that all the missing data that you have, replace it with NA. So easy for us to understand that NA is missing data. Actually, missing data is actually data. Only that is missing. So this is NA. We have a lot of NA here. If somehow when you run your code, some error is happen, maybe some of the data that you have is not missing data is not replaced with NA. So make sure that everything is missing data is replaced with NA. So now let's see. Okay, now I have read this. I read this file just now. Station Johor River Basin daily rainfall data, and then I will read only the column 4 until the end of the column. So read this data. That means I read from column 4 here until column 24. So it starts with station 1 until station 21. So if we view the data, we can just use the view function that too. We can see view data. It will show you, this is what I am reading right now from station 1 until station 21. So I'm reading this station. So now let's look at dim that too. This is the dimension. So we have here, we have 21 column and 16,801 row. So it's confirmed here we have 21 variable that we want to, or station that we want to assess. And then we can do diagnostic. This is the first statistic that you can calculate for missing data. First, you can calculate diagnostic. Here you can use this function, diagnose, and then read our 21 station just now. So this is diagnose. So we can view the result. You can see you have a lot of information. For example, from station 1 until station 21, we have types. There is numeric. Yeah, we have rainfall data is all numeric. It's not categorical variable, so it's numeric variable. And then it will show you missing count. This is the number of missing data, and then missing percentage. So you can see here missing percentage is here, 16%, station number 1, and then it's all the highest missingness is 19%. Station 717400001. They have 19% missing data, and then we also have unique count, and then unique rate. Unique count is and unique rate is more or less like outlier. But if you don't understand what does it mean, I will not explain it here. But you can just check the result, diagnose here, like example here. But you can just use ChatGPT. For example, you can use here. I will show you how you can use ChatGPT. I can just put here in my here it tell you. For example, I will ask it. Describe the result of unique count and unique rate from this output. I don't know. You can just put it something like that. Just ask ChatGPT what the meaning of that result. It will tell you what is unique count. Unique count is a variable referred to number of distinct or unique value present in the variable. How many different value occur in a particular volume that is unique. Unique rate typically refer to proportion of percentage of unique value, something like that. So it will how to interpret the result is something like that. It will tell you all the definition and everything. Just use ChatGPT. I will not explain what all the statistic here is not this tutorial will not tell you what is the meaning of all the statistic. You can find it yourself by using ChatGPT or Google by yourself. So it's quite easy, straightforward. Okay, now we have diagnose the first statistic. you can use this statistic and put it in your table for or something like that. What you want to show, missing data, of course, it's very important. Missing percentage is very important one. Missing count, I will not use that one. Missing percentage is very important. You can make it into maybe 2 decimal places and then use this missing percentage, or you can use unique count, unique rate, or something like that, and to make your table more comprehensive. Okay, now we have diagnose. Now we can calculate standard deviation. So this is standard deviation. So we have uh, 21 station just now, right? So I will calculate all this, each of the column. So we have that 2 just now. We calculate for certain station, all of station name up here. I will calculate here. So it's X here. There is X here. So I need to put X because I don't like number for column head. So I will change here all to X. So that it will easily understand that what our reading is actually column head. If we put number, then it's quite difficult. It can be confusing for R because it is case sensitive. So I will change all here to X in the beginning of each of the station number. Yeah. So almost finished. Okay, finish. I will save it, close it, and then I will read from the beginning again to read the right data. Okay, it's there. It's all turned to X. So we have dimension just now, and then diagnose. We do the diagnostic, and then we calculate the standard deviation. So all this function will calculate a standard deviation for each of the station. So we can calculate each of it, and then combine all the result by using cbind function for date 3 here, date 3 until date 23. Use the standard deviation, and then cbind everything, and then you can calculate the variance. To calculate the variance, you must know the length of your data first. So for example, the length of I will take this the length of the first station because the length is all the same. The length of all is the same. So you can calculate the length, and then you can calculate the variance. So that for this station, so missing data is 2 times n minus 1 per n. N is the length of the data. So you can calculate this variance for all of the station from variance 1 until 21, and then just the same thing, cbind all the result so that it will combine into one column, something like that. And then you calculate skewness. This is how you can calculate skewness. You can use skewness function. So the same thing, that one you can calculate all the station, 21 station just now. Make sure that NA is equal to 2. Okay, skewness. And then you can cbind again all the data, combine everything using cbind function. And then I will put the result here in this the same folder, so working directory. So we have diagnose, standard deviation, variance, and skewness. So this is diagnose for my station, standard deviation, variance, and skewness. So I will write everything in CSV file. So we will have a result for diagnose here, and then we also have result for standard deviation, SD, and then result for variance, and then result for skewness. So let's write it down. Oh, skewness result. Skew result. Okay, it's the same thing. So we have diagnose here. We have diagnose. We have standard deviation. we have skewness and variance. So we can open all of these 4 files. It will give you all the result. Okay. So we have the result for the first one just now is the diagnose. You have missing data and everything. It will give you, it will print all your data into CSV file, unique count, unique rate, and so on. We will explain this one. And then, yeah, we have the variance. This variance for all of this all station. Variance is and standard deviation is two important metrics because it calculates how the variability of the data in your data set. You can just transpose it and then you will get the, yeah, in one column, something like that. Okay, and then skewness data, you can put this data into one table, another table. So your table will become very big. It's up to you. And then you have standard deviation. This one is standard deviation. This is standard deviation for maybe standard deviation 1 until standard deviation 21 station. So all of this result will give you some of the statistic for your missing data. So we can add more actually. So I have wait. I'm sorting. This is I'm sorting the diagnose result just now because as you can see, diagnose this one diagnose result. Actually, the data is not arranged properly. I want is to arrange like this from smallest to largest. I want it to be smallest to largest so that I know which station has the highest missingness and the lowest missingness. But I don't want to use Excel. Using R is better. So I'm sort it everything that to diagnose and select unique count, unique rate. I want unique rate and unique and then missing count, and then I sort the data. I have sort the data and then put the working directory also in the same place. This here in the same place. So I'm sorting the diagnose data just now. So it's there. Sort this. So as you can see, it's actually arranged the data from the highest missingness to the lowest missingness. So I know this station has the highest missing data and this is the lowest missing data. There's just some coding that I do just to make life easier for all of us. Okay, now let's see. Close everything first. Let's see. Okay, it's still there. Okay, now we want. This is diagnose numeric variable. Diagnose numeric variable. Let's see what is it actually. I will put everything in the same folder. So diagnose numeric. Let's see. So diagnose num. So the result is diagnose numeric. This is another statistic that you get. Some of the result you can get minimum. What is the minimum rainfall? What is the mean rainfall? Median, quarter 3, quintile 1, max rainfall. This is some of the important value max rainfall, because we want to see in daily rainfall how much rainfall is the highest during the in one day. Or if you have monthly data, you want to know what is the highest rainfall and when it happened, something like that. Is it on December, January, or something like that? And then how many zero minus outlier? This is also important. Outlier. Some of it is defined as outlier. How many outlier is in your data set? And or you can calculate how many percentage, because outlier is important because you want to know does your data influenced by other large-scale climate phenomenon. Like maybe your rainfall is influenced by ENSO or influenced by MJO or influenced by Borneo vortex or something like that, that causing the rainfall becomes extremely higher or extremely lower. So that is become outlier. This is outlier. So it is important information also. Okay, now that is another result, diagnose numeric, and then I filter negative. So this is filter for negative or zero value, illogical for certain value. So I first diagnose the data because sometimes our data have this our data, right? When we collect our rainfall data, some of it missing data, and some of it error. Some error happen in your data that there is some what we call negative value. So rainfall is impossible to be negative, right? There is no negative rainfall. The lowest rainfall is zero or some NA, but no negative rainfall ever occur. So just in case that your dataset is suffer from this kind of error, you can run this code. Just run this filter for negative or illogical for certain value. So you can diagnose this dataset, diagnose, and then let me check first. After I have diagnosed it, it will become diag 0. Diag 0, okay, see. Yeah. After I am removing the data with the negative value just now, then you get the right numeric analysis, something like this. So use this one. Okay. Now, this is the outlier. Just now I show you that we have outlier, right? Outlier. Now we want to diagnose that outlier. What does this outlier mean? So for this one, we can use diagnose outlier function here. Run this one, and then we put the result in the same folder, and then diagnose outlier. Just use this function for the same data, that too. So we have diagnose outlier. Okay, now we have diagnosis for outlier. So we have a lot of outlier count. Just now we have outlier count. Now we have outlier ratio, outlier mean, with mean, without mean. So this is the most important one, outlier ratio. How many percentage is on from your dataset is have outlier. So for my dataset, we can see here there is up to 10% is outlier. It's quite high. So we know that extreme rainfall happen in this station up to 12%, 15% is occur. There is influence from ENSO, from La Nina, from El Nino, or something like that. Again, I will not explain what is all this statistic mean. You can just use ChatGPT or whatever just to understand, or try to Google what it means. So if you want to use certain statistic, you can use it, but it's up to you actually. There is a lot of result. So now we want to visualize our outlier just now. You can just plot outlier. For example, we want to plot outlier for this station. We have one station. We have a lot of station just now. We have this one. We have station, this 21 station. You can just take the heading name here, and then you can plot it. Okay, now you can see what is how the outlier looks like in your data set. So with your outlier, it's like looks like this. If outlier is removed, the data will looks like this. So usually I will not use this plot. This is just fancy plot, something like that. And then you also can use visualize all numerical variable with outlier ratio of 5% or higher. You can use this code just as you see just now. This will calculate all the station actually. But if you use RStudio, then easily you can look one by one. But don't need use this one, because that's why I have this plot to look one by one, and this plot to look every all plot in one go. So actually this plot is unnecessary. It's just fancy plot. I don't know if some people want to use this plot, then it's okay. And then this is the most important one, Pareto chart. Pareto chart. this will visualize a relationship between variables, including the missing value. So this Pareto chart, you can use it and put it into your research manuscript. I will show you. So for this Pareto chart, you need that too. This is the from station 1 until 21 station. Make sure you write it properly here. And then use a plot na Pareto. And then this is the main, this is the Pareto chart for rainfall station. If you want to do for temperature, you can change here. This is the title of the plot. And then the cold blue, and then any color you can use. So you run this one. And then you will get a very nice Pareto chart for missing data for rainfall station. So you see Pareto chart here, it will show you missing grade. If there is less than 5%, the data will be considered good. If less than 10%, okay. Less than 20%, not bad. And less than 50%, bad. And less than 100%, then this data is not good. So you see it arranges all the data based on color, the cumulative plot also there. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 data is less than 5%. So from here, I know that I can, if I want to generate missing data later on to 5%, I will use this station. If I want to generate missing data up to 10%, I will use from here to here. And if I want to generate missing data up to 15% from this station, how many stations? I know, just looking by this chart. So you can use this chart. You can just copy bitmap and so on, put it into your research manuscript. So it's very nice, right? You can use this. So that is Pareto plot. And now we want to use, we want to have a table also, right? Easy for us to put the data into the manuscript. So we can provide a table to view the missing value. So you can use diag table. This is just the name here that I will use, print. So Platno NA Pareto just now. Select, this is blue plot equal to false. So we don't want to plot, we just want to print the result. Okay. Okay, now we put working directory in the same place. Okay, working directory. And then this is the table of missing data. So I have this table of missing data. Okay, now you know some table is here, frequency, how many frequency, ratio of missing data. This is very important. You can just change the 19% or something like that. This is the grade, cumulative. This is most important one. It will give you the grade just now. The grade of missing data. Is it good, okay, or not bad? Something like that. Less good mean less than 5%, okay, less than 10%, not bad, less than 20%, something like that. So this is some of the result that you can use. But they have cumulative, ratio, frequency, variable is the station data. It's up to you what what metrics you want to put into your table. Later on, because you have a lot of metrics, a lot of statistics, that it's up to you which statistic you want to put into your table. So next, this is intersection of missing value. This is how we want to visualize a combination of charts. So we use a plot na intersect. So intersect of missing value. We want to see missing value is the intersection between missing value. So this is the station. You can see some station they have missing value is intersect here. But then there is other, it's not missing value, so information can be used to input that missing value. That is kind of how we try to interpret this result. So this is a very nice intersection of missing value. The result, you can put it into your paper also. But some reviewer don't want this table, you can remove, but it's okay to put it. I put it, so it's okay. And then we visualize n variable containing many missing value. It's the same thing that intersect just now. Just the same thing intersect. Okay. Okay, I think that's all for some of the missing data analysis that we can do to understand how the missing data in our station. Actually, we have another statistic where we evaluate the statistic of rainfall, but that is for complete data set. It's better for complete data set, but this one is for missing data assessment. So, for example, here I show you how I put my result. Actually, we have let's see my paper that has been submitted and published in Apply Computing and Geoscience. So you can see this data quality assessment. I put it in section 5.1 data quality assessment. So I explained before imputation, I do a data exploration. We analyze the data. So how many, the range of missing data is how much for all station, what is the highest rainfall data, the mean value, uh, and then when does this occur during northeast monsoon, and what is variance, standard deviation, coefficient of variance, something like that, and then low percentage of zero rainfall. uh, so percentage of zero rainfall is also very important. You can use it to show that is it in your place in that station rainfall usually occur or not, something like that. Outlier ratio. So there is two tests also, the Welch two sample t-test to evaluate homogeneity and potential shifting in the station. Also, you can do this one, Welch sample two test. So I will put in the code Welch sample two test. Let's see, t-test. So I need to t-test. Okay. So this is the t-test. This is the t-test also will interpret the result. And this will also the purpose of weld sample to test is, I will put it here. This is wedge to sample t-test. This is to evaluate homogeneity in the dataset to understand if our missing data time series is homogeneous or not, or if there is other influence. Okay. So the same thing, I will show you how to do this work two sample t-test. I will not explain what is t-test or something like that. You can do the learning by yourself, and then you can do the same folder just now because we use the same data. Here. Okay. Okay, we use the same data set, that we use, which is this one. That just for example just now, the same data set. Now we want to calculate that too. First, we calculate the length of the data to get the n value. So the length of that 21. This is so when we calculate t-test, we calculate one by one. We can calculate either for the first station or the second station, and then you need to change here. For example, I'm calculating the last station 21, column 21. So column 21 is here, column 21 station, the last one. So I'm calculating n, and then when one, first half of the time series, and then second half of the time series. Okay. Now I will check for normality assumption. This is check for normality assumption, normal QQ plot, and then we have also normal QQ plot for the first half and the second half of the time series, so that we can compare is it homogeneous or not. Okay, if the data is not normally distributed, perform a log transformation. So we perform a log transformation for RAN 1 and RAN 2, which is the first half and the second half of the time series log transformation. And then we perform t-test. So t-test for RAN 1 and RAN 2 by using t-test function. So we will get our result. So we can print the result here. This is our result. You see, we have well 2 sample t-tests here. But it's quite difficult to understand the result here if you not don't have a basic statistic. Other way, you can use this copy and then use ChatGPT to interpret the result for you. Describe, for example, I use that one. Describe uh, describe this result. So I copy this result just now, right? I put it into ChatGPT just to help me to describe the result. So the result, so RAN 1, RAN 2 test, this is where 2 sample t-test. T-value is 20, degree of freedom, p-value, hypothesis, confidence level. Based on the result, negative value, the summary state different with having a lower mean, something like this. This all give you the result. But still, we want to this is another code that I prepare. This will interpret the result. Interpret our result just now is if there is evidence of inhomogeneity in the time series or not. So I run this one. So there is evidence of inhomogeneity in the time series. So for station number 21, just now the data, this station is inhomogeneous. That means there might be there might be human error, or there might be influence from El Nino or other global climate phenomena that influence the rainfall for this station. There is 2 hypotheses. Is based on if the result is inhomogeneous. It's either because of human anthropogenic effect or natural climate variability impact. So you can discuss. Very long discussion. You can say non-stationary because of this large-scale climate event. You can do the study in the literature to understand. See, this is my result. I put two of this table in my two of this chart in my paper, and then another one is this is the result that I do as the table, all the statistic just now, right? So I have missing value. So the bold here also mean inhomogeneous station. Bold. You see, I put just bold here. That means this 1, 2, 3, 4, 5, 6, 7. 7 station is inhomogeneous. That means that station, if we put in the map, maybe in some area is influenced by the large scale climate phenomena. Some group of station, something like that. We can see it spatially also. So I do how many percentage of missing value, what is the mean rainfall, mean daily rainfall, maximum daily rainfall, standard deviation, variance, CV, coefficient of variance, skewness, 0%. How many is 0%? Which mean is zero rainfall. How many is zero rainfall? Outlier ratio, T statistic value and P value just now for this wedge sample T test. Statistic and P value. So you will get this very nice table from all the statistic that I show you. Actually, there is more statistic, but it's up to you. It's subjective, right? It's up to you which statistic you want to put into this table. I think that's all for today. This is how you can, some of the statistic you can use for missing data assessment. But if you have any other statistic that you can calculate, it's up to you. You can calculate it. You can add it more, and you can improve if you find some any other table. But I have do another one to visualize missing data. But I think Pareto chart is very nice. It's better than another one that I use. But I have provided that tutorial previously. So I think that's all for today. Thank you for watching.